time I figured it out. Yeah, baby, I need a plan. Oh, to understand that life ain't only supply and demand.
Hi folks, this is Professor Watts. Welcome to the tutorial for Excel File 2 or Excel Practice 2, which is creating supply and demand inside of Excel. Let's jump into the first file, which is called Excel 2 Supply and Demand Model. And let's just start off with building us some demand and supply curves inside of Excel. So you might remember from class, if you were there, that I was doing a demand curve for Culver's Burgers. And I basically remember a demand curve is just a list of how many of the product people will buy at various prices. So you can see I have a grid here. I've got the product specified, the time period, quantity per week. I've got a list of prices, and I'm going to survey here 6 people, A, B, C, D, E, and F, and to say how many would you buy at this set of prices. Okay, and to simplify things, I've just got some pre-baked data down here, so I'm going to copy and paste that in. Okay, so you can see that I've ranked these in order of decreasing per individual demand. So person A has the highest demand curve. Nobody's buying any burgers at $10, $9, $8, but see person B starts buying at $6, and by the time we get down to $2 and $1.50, person A is buying quite a few burgers, right? So that would be person A's demand schedule or demand curve, and then we're graphing that over here. You can see that's the kind of dark blue with the diamonds. That's this line right here. Try that again. Person A's demand schedule is this data right here, and the graph of person A's demand curve then is this line, this individual blue line right here. Okay. So person B then would be in the red line over here, person C, and you can see that as I added people here, they happen to have a lower level of demand, meaning they're not going to start buying the product until the price gets even lower. Person F not even buying until it's down to $3, and buying fewer units of the product at any price. All right, so some people have a higher demand, some people lower. What we probably really care about is the overall market demand. So that's the total over here, and the way we achieve that is just by summing up horizontally the quantities each individual person will buy at any price. Okay, so at $4, everybody here in our market is going to buy 9 burgers. If the price falls to 3, everybody buys 14. And that's given by the light blue line over here. That's what we would call the market demand curve. Okay, so here is my market demand curve. Now, what I want to observe is that as we change the numbers up here, we're going to change the height of that market demand curve. Okay, so let's, for instance, take away some consumers, right? And we think about the determinants of demand. Well, number of consumers is one of them. If I reduce the number of consumers, I'll take away consumers E and F. Let's say they decide they don't want to buy Culver's anymore for whatever reason. The demand curve went down, right? Watch that again. I'll undo it. I'll redo it. I'm going to take away consumers E and F, and the demand curve falls to a lower level, right? So as I take away or add consumers, I shift the level of demand curve, right? Let's say that there's some negative press, people are getting sick at Culver's, God forbid. That would reduce people's preferences. So I paste in a new set of values where all these numbers are lower. Well, that's a lower level of demand, and the demand curve is shifted down. Let's say I increase, let's say Culver's does a lot of advertising and ramps up people's preferences. So I'll paste in some higher numbers here. And that makes all the numbers go up, and you could see the demand curve shift back up, right? So as those numbers change, this list change of the amount people buy at different prices, and that is what's shifting demand up and down. Remember, if we're just talking about a price change, so for instance, I'm going to go in price from 5, let me highlight this, to 4. I'll highlight it another color. Okay, if price goes from 5 to 4, what happens to demand, the level of demand? Well, nothing, because it's the same list, right? It's the same list. What we're going to do is just move along that list right here, and then graphically go, move from here to here. People are going to go from buying 16 burgers to 14 burgers per week, right? So remember, changing price, we only move along the demand curve. We move up and down this list. To move the demand curve itself, I have to be changing these numbers. I have to be looking at lower numbers, right? I can paste in a lower set of numbers here. That made the demand curve shift all the way down, right? Or I could paste in a higher set of numbers. Okay, so we have to start off with that distinction between a shift in the demand curve, which would involve underlying determinants, tastes, preferences, incomes, price of other goods, number of consumers, expectations, okay, and distinguish that between changing price, which just changes quantity demanded. Okay, so I've done that for demand. I'm going to go ahead and skip the supply curve because we haven't really gone into that in detail in class yet. But as you can imagine, it's the same. It's basically the same phenomenon. We're just going to have a list of the quantities people will sell. The companies or producers of the product will sell at various prices, and it's just going to have the opposite slope. If I was doing a supply curve, it would look like this. I'd have the quantities and prices supplied by each of the individual suppliers, and then I would sum those up, and then I'd have the overall supply curve, right? So then changing those numbers shifts the supply curve according to determinants of supply. We'll work on the determinants of supply and demand here in a minute. Now let me move on. I want to show you how I build a supply and demand model that we're going to use in our Excel homework problems. And I did this in class, you might recall. I'm not going to require you to do this, but I do want to show you how the background of this works in Excel. I want you to kind of be familiar with this. So all it is a good old-fashioned, remember us, slope-intercept setup. So let me give myself some space over here. All right, y equals mx plus b. And in our case here, we're really dealing with P, because that's on the vertical axis, equals MQ plus B. All right, so when I model demand, all I need to do is set up a slope and an intercept. I've got a list of prices here, and I just need to make Q a function of those prices. So how do I make Q a function of those prices? Well, I'm just going to rearrange this equation so that Q is a function of P. So I'm going to subtract B from each side, and I'm going to get P minus B equals MQ. And then if I divide out M, I'm going to get P minus B over M equals Q. And that's how I'm going to run this in my Excel model over here. So I'm just going to set this up. Okay, I'm going to set up a slope, which is going to be minus because it's demand slopes down. And an intercept, I'm going to set it at an arbitrary level of 10. And then the quantity is just following this function right here. It's going to be P, which exists right here in C5, minus this intercept. I'm going to lock that in, F4, divided by the slope parameter, which is up here in D2, also lock that. Okay, and then I can fill that down, and I've got my demand curve. And as you can see in my graph over here, which I'm having graphed that, there we go. Same thing with supply. I need to specify a slope. I'll just make that slope positive. I'll make that intercept lower, and then I will run the same function, P minus B. So the P exists right there in my schedule. Intercept exists right there. I'm going to lock that so it doesn't slide. Divided by M, which is the slope. I'm going to lock that as well. Remember to lock those cell references if you're creating the model, but I'll do that for you in the homework. And that I'm going to fill all the way down, and you can see, okay, I'm graphing in my supply curve. And let me look at it all together. You can see I've got my equilibrium solver in here. Right now, all I need to do is look at the graph that we've created. I can see equilibrium here with the dotted line, so the equilibrium price is 5, quantity is 5. Highlighting over here in the schedule where equilibrium is. And if I then shift the intercepts, I can shift demand to the right, or I can shift supply to the left, or whatever I want to do. So I can model any of my supply demand shifts here, my scenarios. So that's how we're going to use Excel to model supply and demand. Now, the beauty of this is that we don't have to create the model every time. We can kind of save the model, and we can program it to come up with different starting points. We can throw out different scenarios, and then all we're going to do in the homework is think through, okay, what's happening here? Is it a supply shift or a demand shift? Which direction? And therefore, what's going to happen to price and quantity based on the scenario? Okay, so with that being said, let's jump into the spreadsheet. This is a kind of slimmed down sample version of what you'll be receiving for the homework 1 file on Blackboard, but it's going to work the exact same way. It's going to look the exact same. You'll notice that there's nothing here yet, but we've got a copy of that demand supply model where we have the slope and intercept generated. Data for quantity will be filled in and then graphed over here. Once we launch the scenario, which we do by typing in here G2 equals random number, Let's go ahead and do that. So every time for every scenario, you have to go and type this in and hit enter, and you'll see it populates things. So we have an initial demand and supply situation here. You can see the green, that's our initial equilibrium. That's graphed down here. Equilibrium, price, and quantity are kind of pinpointed by these green dashed lines. Okay, so we start off by finding that equilibrium, price, and quantity. So I'm looking, and I see the initial price is 7 and quantity is 3. So let's go ahead and type those in here. Price is 7, quantity is 3. Okay, now, so that's the very first thing you do. Once you launch a scenario by typing equals random, open, close parenthesis here. Find the initial equilibrium in the graph, type those values for price and quantity. Now we're going to consider the scenario which exists up here. Consumers believe that they are unlikely to need peach flame in the future. And you'll notice I have made up fake names for these products because I don't want us thinking about the product. Okay, the product isn't what matters. What matters is our determinants of supply and demand. So we're going to think through all of our supply demand determinants and pinpoint which one is operating here, and then determine which curve shifts and in which direction. So let me refresh our memory on determinants of demand. Okay, so I've got my demand determinants: type, number, taste preferences, incomes, price of other goods, expectations, number of consumers. Then my supply determinants, remember T-TEP number, technology, taxes, expectations, price of inputs, number of producers. Okay, so it says consumers believe that they are unlikely to need peach flame in the future. Are consumers demanders or suppliers? Well, they're demanders, right? You see number of consumers, that's a demand factor. So I know I'm in the demand factors. Now, which one is it? Keyword here is in the future. They don't think they're going to need this product in the future, so that would be expectations, right? So how do future expectations, how do they impact our action in the present? Well, if I don't think I'm going to need it in the future, I'm probably less interested in buying it today. So I'm expecting that that's going to shift demand down and to the left. So I'm going to have a shift downward and left in demand. And that's not a supply determinant, so supply is not going to change. Okay, now we can go and look for equilibrium 2. And let's go in the graph again. I think it's always best to look at the graph, and I'll highlight this in green. Okay, so there's equilibrium 2, and the price has moved to 6, and the quantity has moved to 2. So we had a shift like this, right? And now we can plug in those values for equilibrium 2. Price moved down to 6, and quantity moved to 2. So all we have to do is fill in these yellow highlighted cells, and that's it. So what happened to price? It went from 7 to 6. Price decreased. What happened to quantity? It went from 3 to 2. Quantity decreased. There we go. That's all there is to it. Let's do a couple more just so we really get the hang of it. Okay, so I've jumped over to scenario 2 now, and the procedure is always the same. We're going to type equals random, open, close parenthesis, enter. That's going to launch our scenario. So it says, producers engage in a successful advertising campaign for Skizzle. Now, first of all, though, we want to find that initial equilibrium. So let's come down to here. Okay, so there's where supply and demand meet based on our starting conditions, which are just randomly drawn. Price is 7. Quantity is 3. Okay, now we can think about the scenario. Producers engage in a successful advertising campaign for Skizzle. Predict the effect of this change on the equilibrium price and quantity of Skizzle. So, advertising. Does that affect consumption? Does that affect consumers on the demand curve, or does that affect producers on the supply curve? Let's think about it, right? What would that be? What would that involve? Would that involve taste and preferences, incomes, price of other goods? Not price of other goods, right? Expectations, it doesn't really say anything about the future there. Number of consumers, right? Anything come to mind here, right? If you're saying taste and preferences, you're correct, because that's what advertising aims to do, right? It aims to kind of increase people's preferences for this product. You could also say number of consumers. Those things kind of work hand in hand. Okay, so in either situation, that's going to make demand go up, right? So we're going to have demand shifting right. Supply isn't changed because that's not a supply determinant, is it? No, so that's going to be unchanged. Equilibrium 2. So let's highlight the new equilibrium. So the new equilibrium's up here at a price of 8 and a quantity of 4. So let's type those values in. Price of 8, quantity of 4. And that means price increased and quantity increased. Let's try another one. Maybe let's see if we can maybe draw a supply shifter here equals random open close parenthesis. Okay, here's an interesting one. Let's find our initial equilibrium though, as always. Start here first. So looking at the graph, here's my equilibrium where supply and demand meet. Price is 3, quantity is 3. So let's type those in. Price is $3 per unit, quantity is 3 units per time period. Okay, now we can go and look at our situation. It says an electromagnetic pulse weapon is set off, destroying computer and cell phone networks, thus reducing the productivity for all businesses. All right, so is that affecting supply, cost of production factors for companies that produce the products, or demand, the consumers' interest in the products, right? I think that sounds like a supply factor, and indeed, when we look through our supply factors, we can say, is it technology, taxes, expectations, price of inputs, number of producers? Hopefully this one's pretty obvious. This is technology, and rare and hopefully never happens, but this would be one of the rare factors that would cause a downward shift in technology, because it's reducing productivity, because it's ruining our the kind of the capacity of our technology. So downward shift in technology. So what would that do to supply? That would shift supply curves to the left. Okay. Higher costs of production and lower quantities supplied. So if you think about why is it shifting that way? Well, higher cost of production, if we want to think about it in the money space, or less offered at any price, if we want to think about it in quantity space. So quantity shifts like this. And now we're looking at this equilibrium right here. So price has risen to 4 and quantities dropped to 2. So let's complete the table. Of course, it's not a demand shifter, so demand's going to be no change. All right, so equilibrium price has gone to 4. Quantity's gone down to 2, meaning that quantity has, or price rather, has increased and quantity has decreased. So we're done. All right, let's do maybe one more. Jump over to scenario 4 here. Okay, and by now hopefully you know the drill. Equals random open close parenthesis. All right, here we go. It says the price of a key ingredient required in the manufacture of Hexteria goes up. So we want to think, is that a demand shifter or supply shifter? But first, let's find our initial equilibrium. So before anything happens, we were at a situation where the price is 7 and the quantity is 3. So let's plug those values in. Price is 7. Quantities 3. Okay. Now, we can think about whether this shifts demand or supply. Price of a key ingredient. Price appears in both demand and supply. I've got price of other goods for demand, and those are specifically substitutes or complements. And then I've got price of inputs. So which one are we looking at? Well, it says a key ingredient required in the manufacture of Hexteria. That would be an input, right? So I'm definitely looking at this right here. This is a supply factor. And what is it doing to the supply curve? The price goes up, right? So think over here on the price axis, price is going up. That's going to pull the supply curve like this with it, right? So I know S2 is going to be something like this. It goes up in price space, it goes down in quantity space. So which direction are we shifting that? We're shifting it to the left. So I know it's not a demand shift, so that can be no change. And the supply shift is going to be to the left, and there it is, our new supply curve. And let's highlight that. So we've got a new equilibrium right here, right, at a price of 8, quantity of 2, right? And just to review, the concept of why does price move to equilibrium? Well, if price didn't move, suppliers would only be willing to sell this much at their higher cost curve, and that would be less than people would want to buy. And that would cause a shortage, right? Here, the quantity demanded up here is higher than the quantity supplied, so we'd have a shortage, and markets hate shortages, so the price is going to get forced up. And price gets forced up until we get back to an equilibrium. Okay, so we can plug those new values in. The price moves up to 8, and the quantity moves down to 2. And that means price, of course, has increased. I'm thinking about what happens to price here, and quantity has decreased. Okay, so that's all there is to it. I would encourage you to write down your list of demand and supply shifters, type number, T-type number, have that handy when you're working on these problems, and just work through each scenario carefully. And then when you're done with the entire assignment, you will save it according to the instructions I gave in Blackboard. It's going to be last name, first name, homework 1. and save it, upload it back to Blackboard where we downloaded it, and then I'll get these graded very quickly, and we'll maybe go over it in class, and then I promise you will expect to see some problems like this on the first midterm, right? So you want to make sure you know what you're doing here, and practice, practice, practice. You can save the file, upload your homework, and then you can download it again and just kind of work through it again as many times as you want for practice purposes. There's a whole bunch of scenarios in here, so if you do it 2 or 3 times, you probably won't see a lot of repetition in the scenario. So it'd be really good practice for you just to keep working through this assignment. All right, folks, so that's it for homework 1. Email me, of course, with any questions. See you soon.